Today we are going to study about eigen values. The question which you send me, in that you need to calculate eigen values in the control system. Okay. So basically, how can we find out the eigen values? Like suppose we'll have one matrix. I'm taking an example of 3 by 3 matrix. 1, 2, 3, 0, minus 2, 6, 0, 0, minus 3, right? So this is your A matrix they have given. Now to calculate the eigenvalues, we need to calculate the value of lambda. Okay. Now see what is lambda. We'll have the standard equation lambda cube minus p lambda square plus q lambda minus determinant of A is equal to 0. We need to put it all the values p, q and a, then we'll be able to solve the value for the lambda. Note down this formula. Now you should know what is basically p. Okay, p is the sum of diagonals of A. Like suppose we'll have this matrix, correct? In this, as you know, the diagonal of the matrix is 1, minus 2 and minus 3, correct? So it would be how much? Sum of diagonals means 1 minus 2 minus 3 is how much? Minus 4. So we got the value for the p, correct? Similarly, we need to calculate the value for the q. What is q basically? That is sum of minors of diagonals. See what is exactly the minors. Minors means, as you know, if we take the determinant, then in that case we'll take one, means we'll leave this row and we'll leave this column, right? Then what is left? That is minus 2, 6, 0 and minus 3. This one is left, right? Now in the second case, if we'll leave, then we'll go for 2, right? Then if we'll go for 2, we'll leave this row and we'll leave this column, correct? Like it would be 1, 2, 3 and minus 2, 0. So what would be the left term in that case? 1, 3 and 0, minus 3. Basically for 2 we'll leave this and this one, second, plus again for the third one we'll leave the third row and third column. Then what is left? 1, 2, 0, minus 2. Okay, I'm telling you one by one, you won't be able to understood. Like for the first case, like this was the matrix 1, 2, 3, 0, minus 2, 6, 0, 0, minus 3. So now in this case, for the first case, we leave this row and we leave this column. Then this one is the left matrix, minus 2, 6, 0, minus 3. Correct? Understood? Now for the second case, we'll leave second row and we'll leave second column. Okay. Now what is left? 1, 3, 0, minus 3. Correct? Understood? Now for the third row, we'll leave third row and the third column. Oh, sorry. We'll leave third row and the third column. This is the third row and third column now. So what is left? 1, 2, 0, minus 2. So for first row, first column. For second row, second column. For the third row, third column. Got it? Okay. Now you need to solve it, like it's the determinant, and as you already know how to solve the determinant, that is minus 2 and minus 3. would be equal to how much? 6 minus 0, right? So this would be the value plus. Now do it for the rest of the terms. So final answer will get it as a 1. So we got the q value also, that is 1. Now what is left? Determinant of a. And as you already know, how can we calculate the determinant of a? That is 1, 2, 3, 0 minus 2, 6, 0, 0 minus 3, right? So now can you calculate the determinant of this matrix? Now you know the numbers, right? And tell me the value. So after solving it, you will get the value of determinant of A is 6. Okay. Now tell me, any doubt up to here? Okay. Then in that case, then what? Now what we need to do, we need to put the all the values in the given equation, right? So I told you that would be lambda cube plus uh, p lambda cube minus p lambda square plus q lambda minus determinant of a is equal to 0. So as you can see that first is positive, negative, positive, negative. So lambda cube will remain as it is. P value we already calculated, that is minus 4. So minus and minus 4 will become plus 4 lambda square. Then q lambda, q we got it as a 1. Then 1 lambda minus 6 is equal to 0. If we'll solve it, then we'll get lambda is equal to 1, minus 2 and minus 3. So from here we'll get the eigen values, that will be 1, minus 2 and minus 3. Understood? I'm taking matrix. For that we need to calculate characteristic. How can we get characteristic? That is a minus lambda I is equal to 0. So a, as you know, how much? 5, 1 minus lambda I is the identity, so it would be lambda 0, right, is equal to 0. If I'll solve it further, then it 5 minus lambda minus 4 minus 0 plus 4, then 1 minus 0, 1 minus lambda, okay, is equal to 0. Now we need to take the multiply, that would be 5 minus 2 minus equal to 0, correct? If I'll solve it, the 10 lambda minus 5 lambda plus lambda square 4 is equal to, we'll get lambda square plus 6 is equal, now we got this tick. Understood? So from here lambda, calculate lambda. After solving, lambda is comma 1 means are the eigen. Write down this point one more, that if you get eigen on left half plane, left half of S plane, then in that case your system is stable. Stable means, like, suppose if you get there the real axis and in the negative, So in this case, the system is stable. But if you'll get the values on the right half plane or on the imaginary axis, then in that case, system is unstable. That case, system is unstable. In this case, you will get the positive value. Positive value will lie on the right half of plane. So in this case, the system was unstable. Understood? One of the step input will have different output, like different outputs at t equal to 0 output, and will have constant output. Like at 8 p.m. entered, okay, and you switch on the fan, and the fan will remain on or it will become off automatically at 8 you enter the room and you switch on the fan. So it will remain on or it will change. It will on. Basically at equal to 8 p.m. switch on the fan and will the output will be constant for all the values, right? This can be replaced by a or any constant. So what we can write it down for, if t is less than, then output is what? So because for t is no output greater than equal to 0, that case output is k, right? We write it like this. Understood? Now thirdly, like if we will have unit step input, that case k is equal to 1. Got it? Down. Next, put the ramp. Okay. In the ramp input will have a graph, like means it is constantly increasing, continuously increasing at a speed of 1. Ramp input is represented by r of t and its slope is suppose a. So how can we r of equal to a t for t greater than equal to, and it can be like 4 if t is less than 0. The output is 0, correct? One more thing which you need to know, that the Laplace of the step input is 1 by s. You know na Laplace that you have studied in maths class? S transform of the step input is 1 by s, and for this one Laplace transform for the ramp input is 1 by s square, because this is the next input is parabolic. As you know, parabolic output is correct. Parabolic shape. So in this, it by again r of by 2 equal to 0 for t less than, and its ramp function kind of, so its slope is in Laplace by. Last but not, impulse function. For impulse function, have at equal to 0 will get output. At t equal to 0 output, not before that, not after. So impulse by delta of t. Now you tell me, how can we write down this state of equation? Like at t equal to 0, what we can write it down? Tell me. Equal to 0. Yeah, k. And if t is not equal to 0, the output is correct and its Laplace is 1. Basic form of table will have impulse, then its Laplace have step by a, have ramp, then its Laplace is 1. If have parabola, Laplace sorry, it was now the next part. If suppose they have given you any kind of system, the form block diagram. This is the forward path, and forward path is always represented by of, and this is the feedback path. Why it is called as feedback? Because as you can see, output is connected to the, okay, so it's a feedback path that is represented by, it is known as reference. Here we'll get input of CS, here we'll get output in the form of RS. Like this is a standard block diagram. You know about it, right? Maximum time it comes in. So whenever we need to calculate ESS, ESS stands for the steady state error. Remember, in your question also they ask you the steady state error, right? Whenever they'll ask you for the steady error, will have particular that it limit s tends to s dot r of s the output divided by 1 plus of s of, this is the formula for the steady. Okay, understood? Now the next thing is we have to calculate the error constant, that is known as static error constant, or we can static error coefficient. Basically it is divided into categories. One of the constant is positional error constant. Positional error constant. Another one is the error constant, is denoted by K. Another one is the acceleration error constant, that is by of. So in every time, like in your, they'll ask you either KV or K. Will have particular formula. That KP formula is like limit of S in of, okay. Similarly, we'll have formula for KV. KV equal to limit S into U of S H of. As you can see that there is no S, but there is S in the velocity at. And for the acceleration error constant, we'll have formula that A is equal to limit S tending to 0, right? So what would be for that? Ka is S square S and H of. So here in Kp will not have S, in Kv will have S, then in error constant K will have S, correct? Next, for this one we need to calculate the steady state error, particular different for Kv and K. So we'll have formula ESS divided by A1 plus Kp, and for Kv we'll have ESS is equal to A divided by Kv, and for this acceleration error constant we'll have by Ka. Okay, so this one is basically for the step input, and this one is basically for the ramp input, and this one is basically for the parabolic input. Okay, understood? Will the formula based on. Okay, now see, they have given the system of S is equal to 20 S plus 3 divided by S plus 1, and they have said UNFB. UNFB means unity feedback, and for this they ask you first the type of system. You know the type of system. How can we calculate the type of system? I told in the body plot, like I told, we'll have type 0, type 1 and type, right? If we'll have in the denominator S power, that is type 0 system. If we'll have denominator power 1, is 1 system. If we'll have in the denominator S raised to power 2, that is type 2. Now as you can see in the denominator, there is S raised to power 0, because anything raised to power 0 is always equal to 1, correct? So anything that would be equal to 1. So this is type 0 system. So they can give you any type of the system. Understood? So its answer is type 2 system. Now in the second part they ask you all error coefficient. All error coefficient means they ask you the value KV. So as I told you, the formula KP is how much? Limit S tending to U of S of S, correct? So U of S is this one, 20 S plus 1 divided by S plus and as it's a unity feedback, so unity feedback means HS equal to 1, correct? Now substitute the value, that will get 20 S plus 3 divided by plus 1 plus 6. Now see that in this case we have to convert the equation in the form of 1 plus S, like remember we have done in the Bode plot also. So that would be 20 into, I'll take the 3 common, that 1 plus S by 3, correct? Similarly it would be 1 plus S, I need to take a 6 common, 1 plus by correct. So if I'll cancel out, it become 10. So the final answer I will get n 1 plus s by 3 divided by 1 plus s 1 plus s by 6. Correct? Now I need to put a limit on this number. Limit of s. If I'll put the value s is equal to 0. Now can you tell me what would the value got it? Our answer came equal to 10. Now similarly you need to calculate s 10. Oh, now put the value by your own answer for the KV. Yeah, see how can we solve it? S of s n 1 plus s by 3 s 1 plus s by. Now in this case limit s tends to put s is equal to. So this would become 1. 1 plus 0 is become 1. 1 plus okay, and this one s is equal to, so everything multiplied with the 0 come 0 only, correct. So finally we got it kv as 0 because now do it for the aa is what, x square of s limit again s tends to do it. So for this would be equal to, now in this question only ask you the steady state error. Third part ask you how to calculate steady state error when subjected to a step of magnitude. Like suppose I told you this error for this one for the Kp will have the formula A divided by 1 plus Kp, correct. So for that A is the magnitude that they already give it to you, that is 2 divided by 1 plus Kp. Kp we already get it, that was how much, as a 10, right. So Kp, then now we can solve it, then we'll get the by 11, that is 0.1. Understood? So now you can ask me, ma'am, why you have taken for this particular, why you didn't take another formula? The answer is, as you can see this side, for the step input we always take the formula of steady state error as this one, A divided by 1 plus Kp, correct, for the step input. So in this case also this side for the step input for the magnitude, as I just told you, the step is like this one, right. Understood? Okay, now I'll give you one more, try to do like in this, they of s equal to 20 divided by s 1 plus 1 plus s, right. And in this case also find type of system, and you need to find static error coefficient, that is again Kp. Do it. Which type of if will have denominator 1, that is type 1 system. Now next we need to calculate Kp, and K is limit S tending to of it, that would be 20 divided by 1 plus 4. Already in 1 plus form, so we don't need to convert it. So it would be 1 plus ST1. So if I'll put 0, then 20 divided by 0 1. So multiplied by any term 0. So any term divided by 0 is what? Infinity, like 1 by 0 is infinity. So Kp is infinity. Understood? Now see, we'll do it for Kv. Kv is limit, that would be G, that would be 20 divided by S 1 plus 1 plus multiplied by S also. Correct? So in this case, S and S would be out. 20 1 by 4, 1 plus 4S 1 plus S. Now we need to put S is equal to 0. If I'll put S is equal to 0, that would be the answer. 20 1 plus 1 plus 0 1. The final answer we got it for yes 20 is 0, right? And instead need to calculate steady error. Your work question, that unity feedback they have given professors, they ask you coefficients of all these. No, do it, not do it. Write down another one. Plus S 1 plus 0.5S 1 plus 0.2. That this question I'll teach. This would be your homework. You need to calculate AP, AV. For your reference, I'm telling you the answer. Cross check. Is going to be infinity, AV is going to be, and K is going